Okay, so continuing with 6.2, let's note that sine of sine inverse, meaning the composition of sine with its inverse, should be x, but we have to restrict this. We have to restrict the values of x. We're evaluating the inverse sine first. So what is the domain of inverse sine? Well, it's from -1 to 1. So we know that the composition of sine with his inverse is x for all values of x between -1 and 1. However, if I were to say, okay, sine inverse composed of sine of x, well, these are inverse functions. This should be x for all values of x. Well, what is the restricted domain for sine of x if I want to evaluate the inverse? Well, that's from -pi/2 to pi/2. Okay, so for all values of x between -pi/2 and +pi/2, meaning in quadrants 4 and 1. So let's do the same thing for cosine. So cosine of cosine inverse of x, of course, is going to be x. However, what is the domain of cosine inverse? So this is for all values of x where? Well, cosine inverse had a domain from -1 to 1. Okay, so therefore, for all values of x between -1 and 1. Similarly, if I evaluate first the inverse composed with the normal values of cosine of x, well, this is x, but of course I had a restricted domain for cosine. So this is for all values of x that are between, my restricted was from 0 to pi. So the restricted domain there for all values of x between 0 and pi. Okay, so for example, let's go ahead and evaluate some things. So for example, so evaluate the following. Evaluate the following. Okay, so number 1. Let's say I have a sine inverse, kitty, of sine of, say, -pi/4. Kitty. So this will be sine inverse of, and let's do regular sine of -pi/4. Okay. Well, what do I want to know? I want to know that my value for x, because this is the second guy, the second node up here, I need that my argument inside is between -pi/2 and +pi/2. Sorry, so is -pi/4 between the allowable domain -pi/2 to pi/2? And yes, it is, so we're okay. Okay. So we have, let's call this y for the time being. Y is equal to, and we have inverse sine. Okay, well, sine of -pi/4 is the same as minus sine of +pi/4, because sine, of course, is an odd function. And the nice thing about pi/4 is that both sine and cosine have the same value. So this is y is equal to inverse sine of negative square root of 2/2. Okay, so this is if and only if. Remember, I never want to deal with an inverse function. I need to rewrite it in terms of the normal function. -√2/2 is equal to regular sine of y. Okay, so at what angle is sine -√2/2 within this restricted domain? And that means we're at the angle -pi/4. Notice I got back what was inside, as I should have, because this is a composition of inverse functions. Okay, so number 2. Let's say we have cosine of arc cosine of 0. Well, if all goes well, it should be 0, right? Arc cosine. Okay. So what do we have here? We have, which color should I use? Let's use green. So I have cosine of arc cosine of 0. So what I'd like to do first is I'd like to rewrite this as cosine of cosine inverse, because that's easier. I prefer the notation. Cosine inverse, if I can write cosine. Cosine inverse of 0. Okay, so what is the domain for the inverse cosine? Let's go back up. So inverse cosine, it should be from -1 to 1. So is 0 between -1 and 1? And yes, it is. Sorry, -1 and 1, check mark, it is. Okay, so what I'm going to do is I'm going to let y be equal to, what's inside there? Inverse cosine of 0. Rewriting this without the inverse. Let me make that double arrow better. So if and only if 0 is equal to regular cosine of y. Okay, so at what angle is cosine of y equal to 0? I claim that angle is 90 degrees or pi over 2. But I said I'd get 0. Well, because I have only done the inside. So rewriting, this becomes cosine of, well, what did I get for arc cosine of 0? I got pi over 2, right? So I can rewrite this as pi over 2 because all of this is equivalent to y. So cosine of pi over 2 is indeed 0. So I did go full circle, check mark. Okay, let's do another one. So number 3, and I guess this will be it for this subsection. So let's evaluate inverse cosine of 7 pi over 6. Okay, so we have cosine inverse of cosine of 7 pi over 6. Okay, we're going to come up with a problem here because cosine inverse of cosine, I need that my value of the argument is between 0 and pi. But 7 pi over 6 is not in the interval from 0 to pi. So what's going to happen in this case? Well, let me show you what's going to happen. I'm still going to evaluate this, so this becomes inverse cosine. Let me call it, say, y for the time being. Y is equal to inverse cosine of, what's cosine of 7 pi over 6? Well, that's a pi over 6 reference angle in quadrant 3, so that's going to be negative square root of 3 all over 2. So this has an equivalent expression. Remember, rewrite it without the inverse. This is equivalent to saying negative square root of 3 all over 2 is equal to, let me do that in blue, is equal to normal cosine, without the inverse, of y. Okay, so at what angle is this true? Well, cosine is negative root 3 over 2 in quadrant 2. So in this case, y would be 5 pi over 6. Notice that that's not the same as 7 pi over 6 because I'm restricted. I have a different domain. So this is because, let me put an asterisk here. This is because cosine inverse of any angle theta must be between 0 and pi.